Hi friends, welcome to this channel. So in this video, we're going to look at problem 60, permutation sequence. This video is a follow-up on problem 3518. So our goal is to see the connection of problem 3518 and the problem here. Actually, in the video for problem 3518, we made a comment which says that after you address problem 3518, you can do an exercise using problem 60. Essentially, you can solve the two problems using the same idea. So here a comment is that if you compare the two problems, both are marked hard by leetcode. Actually, from a technical point of view, problem 3518 is slightly more complicated. So here we are going to use exactly the same idea as in problem in the video for problem 3518, and also we are going to use almost identical code. In other words, we are going to copy the code for solution problems 3518 and then make some modifications. So now let's look at the problem statement. So basically we are given the first n digit integers. So we want to find the case permutation sequence. So here the case is in the sense of lexicographic order, right? So if you look at the three examples, you can digest the requirement. Here, none is bounded above by n is bounded above by none. The reason we use this small bound is due to that factorial is actually can be very large if you have a large n, right? So with that said, let me give you a walkthrough. So I'm going to use n equals 4 and k equals none as an example. So if you have n equals 4, right? So then basically there are 4 positions. You want to arrange the 4 different numbers 1, 2, 3, 4 in these 4 positions. So overall there are 4 factorial ways, that is 24, right? So in other words, if your k is greater than 24, so no valid output, you can also see this constraint, right? K is less than or equal to n factorial. That's why. When we do this, typically first we want to use 1 as the first position. So then we fixed it here, and then we're going to use 2, 3, 4 and to fill the remaining 3 positions. So number of ways for these 3 positions is 3 factorial, that is 6. So you actually can list them. So you put 2 in front, and then you switch 3 and 4, right? You got two options. And then you put 3 in front, you switch to 4. Similarly for 4 and switch to 3. So this way, if you put 1 in the first position, you are going to get 6 possible, the first 6 permutations, right? Then what about 7 or what about 9 in the example 2, right? So then we cannot use 1 as the first letter, right? Because they can only produce 6. We need to try using 2. But we know using 1, it yields first 6 permutations. So now we need to update the k. So k decremented by 6. So we get, if k is 7, you get 1. So in other words, I use 2 as the first character and then arrange 1, 3, 4 in the remaining 3 positions. So number of ways are 6, right? So if you put 2 here, and the first option will be 1, 3, 4, then you switch for 3, right? So similarly, you put 3 in the second position, you switch 1, 4. Similarly 4, and you switch 1, 3. So for k equals 9, so we get 2, 3, 1, 4, right? So this is the return corresponding to example 2. So this, if you're using 2 as the first character, it addresses the cases for k greater than or equal to 7, less than or equal to 12, right? So here another comment is that once you determine the first position, you fixed it, right, like the k here, and then you are using 1, 3, 4 to build the first over here corresponding to k. Overall, it will be 7th, right? So you get it. So in order to get the 9th, I just need to get the first 3 after fixing the 2, right? In some sense, it's recursive. So using 3 as the first letter, you can actually address this 13 to 18, both set inclusive, and using 4 as the first letter addresses 19 to 24. So this will be the walkthrough for example 2 and more. So this walkthrough is in parallel to the walkthrough for problem 3518. So now I'm going to use the code in problem 3518 to write a solution to this problem. So in that problem, we first get the unique letters and their frequency. Here actually is more simpler, right? So we get 1 times n. So for each, so here, count I will be the frequency of I plus 1, right? So because here our number is from 1 to n, but the index is from 0 to n minus 1. So we define this as the frequency of the index plus 1, right? And then also we want to build a list. So this corresponding to build the prefix in the problem 3518, right? So now what we do, so we set the first position, we set the second position, and we do this, right? So basically for I in range n, so we are going to set the first position. Then we want to start from small to large. So for j in range length count, right? This actually is n, right? So here I maintain this. This is for convenience of comparison of code, right? So if we want to use this j plus 1, check or try to use digit j plus 1, right? Notice the interpretation here, right? So we are going to use this decrement by 1, but the condition will be the following: if count j is greater than 0, right? If you have already used that, you cannot do it. So then we are going to decrement this by 1, and then we see how many ways we can contribute using this current character j plus 1 as for the position I. So because we are going to use multiplications, so we set v equals 1, right? And then for so the number of letters, actually the number of positions here is some count. So this is after we do the decrement, right? And then what do we do? So for frequency in count, right? And then so we are going to do with multiply by so mass combination of, so we choose from this number of positions, right? The frequency. Actually we just choose 1. If frequency count, it must be 1 in the current problem setting. But I'm writing this way because we keep problem 3518 in mind, right? So now we have this, then the letters is decremented by frequency. Then we continue, right? We set this position and we set next position. So we cumulate the weights. So you need to recall how we compute the weights in problem 3518. In other words, the second part in the walkthrough, right? After this for loop, we are going to check if the number of weights is greater than or equal to k. So if it were greater than or equal to k, it means that in the current position I, if I use digit j plus 1, I can produce more than k permutations. So then we can use the current character as in the position I, right? So then what we do, we just break. We don't need to retry. This is the one. So if so here actually we need to put it in between, because if thus we have more than k, so we just need to break. So if after the for loop, so if the width is greater than or equal to k, then we're going to do alt append. So we're going to append the current numerics, that is j plus 1, right? So with that done, now let's we need to break, because we have determined to use the digit j plus 1. So this is the one. So once we do this, so we continue to do the build after fitting this position, like here. That's the comment here, right? So then we need to decrement the k by the current number of ways. That is k minus its number of ways, And then so this is the, if it break, if not break, so we're, because for current if using current character as the in the ith position, it's, we do not have enough width. In other words, k is greatly strictly larger than the width, so we minus that one, and then we actually put this count g back. So in other words, we need to try a larger integer or lexicographically larger one. So this will be the case. Otherwise, so what we do? So if after this for loop, you still cannot do this thing. So essentially, you need to return empty. But in our problem here, so we know the key is bounded above by n factorial. So this, we never enter this else block. But I will keep this here in order to do comparison with a problem 3518, especially when you do the comparison by yourself, right? So once we have this, then we get the out. So we just need to do John and the out, and then we are going to return it. So this forms a solution to the current problem system. So now, before we make any comments, let's first do a test. Yeah, it passes the cases. So here, actually, for let's see, for example, this one, so we can do some more tests. Let's see, k equals 9, let's see, k equals 10, what we get? For k equals 10, we get 2, 3, 4, 1. So let's see here, k equals 10, 2, 3, 4, 1, right? That's right. So now let's look at the generic case. Yeah, actually it passes all the cases very fast. So this basically completes the coding part. So now let me make some further comment. The first comment is that we want you see the connection of the current problem system with problem 3518. So in some sense, we need to solve the problem in classes or in types, not isolated ones. So this is the first comment. The second comment is that we have a playlist on backtracking, or we have a channel that contains a lot of playlists. You are welcome to use our channel to do more practice. With that said, I guess that's it for the current video. Thank you.